Hello everyone. The topic for today's discussion is atomic models. So let's get started. The points for discussion for today's topic are: what is an atom, the history of the atom, and the different types of atomic models. So let's move ahead. First of all, what is an atom? Atom is the smallest unit into which the matter can be divided without the release of electrically charged particles. It is the smallest unit of matter that has the characteristic properties of a chemical element. Atom is the basic building block of chemistry. The molecules are composed of atoms joined by chemical bonds that are more difficult to break. Each individual atom consists of smaller particles, namely the electrons and the nuclei, which are electrically charged, and the electric forces on the charges are responsible for holding the atom together. So this was all about the atom, what type of atom it is. Coming on the next one, that what is the history behind the atoms? Many attempts have been made to know as to what is the ultimate particle of matter. The idea of the smallest unit of matter was first given by MAHARSHI Kanada in the 6th century BC in India. According to him, matter consisted of indestructible minute particles called as Paramanus, where परमाणु शब्द का मतलब होता है, परम का मतलब होता है अल्टीमेट और अणु का मतलब होता है particles, which are now named as atoms. A Paramanu doesn't exist in free state. Rather, it combines with the other Paramanus to form a bigger particle which is termed as Anu, and now these Anus are named as molecules. There are different types of Paramanus and each of them they exhibit a specific properties. After the studies of the MAHARSHI Kanada, one more philosopher came here. The person was the Greek philosopher DEMOCRITUS in 1460 BC to 370 BC, and he called the word Paramanu as atom, which comes from a Greek word ATOMOS, which means indivisible. Now coming on the next, let's see the different types of atomic models which were discovered to understand the atoms in a length. So one by one we are going to discuss about them. The first one is about the John Dalton's model. Next comes the J.J. Thomson's models, then the Rutherford model and the Niels Bohr's model, and then lastly we'll discuss about the modern concept of the atomic structure of the model. So let's move ahead on the next one. What exactly the John Dalton's model was? So the oldest concept about the atomic structure was put on the firm foot and was scientifically proved by John Dalton in the form of atomic theory in the year 1803 to 1808. He considered the atoms as indivisible particles that are fundamental building blocks of the matter. The main postulates of the Dalton's atomic theory were that matter consists of very small and indivisible particles called the atom. Atom can neither be created nor it can be destroyed. Atoms of the elements are alike in all respect, but they differ from the atoms of the other elements. The atoms of the element, they combine in small number to form a molecule. The atoms of one element combines with the atom of another element in a simple ratio to form the molecules of a compound. And lastly, the atoms are the smallest unit of matter that can take part in any of the chemical reactions. So this was about the different postulates which was shown by John Dalton in his Dalton's atomic theory. Few drawbacks were there of the Dalton's theory because it was not proved exactly, the proper structure was not proved, which was further in future was studied and proved The drawbacks which the Dalton model had, they were the theory wasn't able to explain the existence of the isotopes. There is no well-defined definition of the structure of an atom, and particles of the atom are divisible. That was proved afterwards, but when the Dalton theory was given, that time it was told to us that it is indivisible. So this was also one of the drawbacks of the Dalton's model that we'll study afterwards. Coming on the next theory, next model, that is the J.J. Thomson's model, which is also termed as your watermelon or a plum pudding model. In 1893, J.J. Thomson, he proposed that an atom can be regarded as a heavy, positively charged sphere which consists of positively charged substances distributed uniformly throughout the whole sphere. The electrons are embedded in the sphere so that the atoms become electrically neutral. The electrons are embedded in the sphere same as seeds are embedded in a watermelon. The mutual repulsion existing between the different electrons keep them changed in the form of the circular shell. Now coming on the detailed structure of the Thomson's model, जो थॉमसन मॉडल को हम एक इमेजिन कर सकते हैं, जो उन्होंने इमेजिन किया था एक तरबूज यानी एक वाटरमेलन की तरह, जिसमें जो प्रोटॉन मतलब जो हमारे जो पॉजिटिवली चार्ज पार्टिकल्स हैं वो वाटरमेलन यानी तरबूज के लाल जो हिस्सा होता है, जो खाने योग्य हिस्सा होता है, उससे उन्होंने तुलना की थी, और इलेक्ट्रॉन्स यानी कि हमारे नेगेटिवली चार्ज जो पार्टिकल्स हैं उनकी तुलना जो तरबूज के जो बीज होते हैं उसके साथ की गई थी. एंड उसके थ्रू J.J. थॉमसन ने एक एटम का स्ट्रक्चर डिस्क्राइब करने की ट्राई किया था, बट अगेन it had certain limitations in it. The limitations of the this J.J. Thomson's model was that it was not able to explain the arrangement of the electrons in an atom or the concept of electron shells. It also failed to account for the spectral lines observed in emission spectra of the atoms. And it was not able to explain the stability of the atoms and the phenomena of the isotopes. Also, it was not able to explain the formation of the chemical bonds between the different atoms. So these were some of the limitations which was seen in the Thomson's model. But of course, it was appreciated a lot. So based on it only, the next model is there, that is the Rutherford model. So Rutherford was a British scientist who in 1911 he performed some of the experiments on the scattering of the alpha particles by a thin metal foil. In his experiment, he has produced a narrow beam of alpha particles from a radioactive substance like your radium, which was placed in a lead block, and it was directed it as a thin sheet of gold foil is present there and it is sparking, emitting the light. So as you see in this picture also, this was the whole setup which was framed by Rutherford through his experiment about to study about the structure of the atoms and about the electrons and the protons properly. So moving ahead, I am going to share with you all a 3D view of the Rutherford's gold foil model experiment. Thomson's plum pudding model was one of the most widely accepted models all over the world for understanding the atomic structure. Meanwhile, several experiments by the different scientists were performed to study the atomic structure and were contradicting the Thomson's plum pudding model. This was the reason many scientists reconsidered the atomic structure and studied it again. Around 1911, a British physicist, Ernest Rutherford, he came along with a famous gold foil experiment, and he did this to understand the structure of the atom. The experiment was carried out by Rutherford along with the Hans Ginger and Ernest Marsden, who carried out the famous gold foil experiment, which was a breakthrough in the field of the chemistry, which helped him understand the structure of an atom in a more accurate manner. In his experiment, he used a source of alpha particles locked in a lead container with a very small slit, which ensured that the alpha particles only came out through a small opening and travelled in a straight line. He selected the alpha particles in the first place as the alpha particles were having a high energy and were heavier as well. So, if we say atom is like a pudding of positively charged particles with electrons embedded in it, then particles will pass straight through it, because the heavier the particle will pierce through the lighter pudding structure of the atom and pass through it. This was the whole reason. Due to the greater mass and energy compared to the protons made by him, the alpha particles of the experiment was used. Next, he used a very thin gold foil on which the alpha particles would bombard, because the thin gold film was established to contain approximately 1000 atoms. Lesser the atom, more convenient the experiment would be. Lastly, a fluorescent screen was used that would help to detect the radiation. Whenever the alpha particles will hit, the screen will glow or emit the fluorescent light, and the track of the alpha particles will be traced properly. Let's see to the working, how to just the experiment worked out. The alpha particles were emitted from the element present in the box, which directly hit the gold foil. According to the Thomson's model, an atom is a sphere of positive charge with a negative electrons embedded inside it, which means the alpha particles will pass right through the atom and hit the detector straight, because the mass of the alpha particles is heavier than the mass of the positive charges. That means they should directly hit the atom and move ahead through it. For seeing all these things, Rutherford was really very astonished to see the whole changes, what the changes were going on, seeing the result, and he found most of the fast moving alpha particles, they pass straight through the foil and hit the detector, whereas some particles, they get deflected by small angles, and very few alpha particles also rebounded. So this was the whole things which was observed, the three observations which were observed by Rutherford in his experiment. These three observations, they made Rutherford think that the plum pudding model which was given by Thomson is not really correct. So let's take a simplified example to understand the inference and everything regarding the experiment. Let's imagine a small ball made up of cotton, and we can just say that the cotton in the ball is very partially distributed, as we can see in the picture also. The cotton in the ball is very partially distributed, and a very thin circle or a sphere is located at the center, which is quite hard and dense that it can even resist a bullet shot against it. If many bullets are shot across this cotton ball, then they will travel straight to the cotton surface. If one of the bullet hits the edge of the central heavy mass, then that bullet will slightly change their path and get deviated. On looking the size of the central mass, it is quite obvious that the central mass, it is quite obvious that only some of the bullets will get deviated. Now suppose if a bullet hits the center directly, then it will bounce back, because we know the central dense mass is too hard for the bullets to pass through as a result. So the postulates which were, the hypothesis which were given by the Rutherford, the first one was most of the space inside an atom is empty, as most of the alpha particles can easily pass through the atom and hit the detector straight. Second conclusion was the positive charge is compactly packed in a tiny entity which occupies an extremely small space inside an atom. This point can be cleared through second and third case of the cotton ball experiment. The bullets get deviated on hitting the tiny sphere of the edge and will rebound when hit on the center. Few alpha particles get deviated. That means there is a possibility that it hits the edge of the positive charge, or it gets deviated because the positive center repels the alpha particles, as they are also positively charged. A very small number of alpha particles will rebound it, as there is a possibility that these alpha particles had directly hit the positive center. But since the number of these rebounding particles is too small, it explains that the volume occupied by the positive center is also very small. if the space which was occupied would have been big enough, then the number of alpha particles bouncing back would have been the greater. So let's say there are gold particles in a foil. He found most of the rays passed straight through the atom. Few rays, they change their path and gets deflected. And lastly, very few particles, they bounced back. Due to these results, Rutherford came to a new nuclear model. His first hypothesis states that there is a positively charged center in an atom called nucleus, and nearly all the mass of an atom resists in this nucleus. Secondly, the electrons, they revolve around the nucleus in a circular path. And thirdly, the size of the nucleus is very small in comparison to the atom's size. However, theoretically, there were many clauses in this hypothesis also. So this was all about the Rutherford's experiment of the gold foil experiment there, about this model. Now moving ahead on the next one. The next model, which was given by Niels Bohr. So according to Niels Bohr, in 1913, who was a Danish physicist, he explained the causes of the stability of the atom in a different manner. Bohr modified the Rutherford's model into an electron and the energy levels. Bohr's model consists of positively charged small nucleus which are surrounded by negative electrons moving around the nucleus in an orbit. His postulates were, the first one, that the negatively charged electrons, they revolve around a positively charged nucleus in an atom. These electrons have a definite circular path termed as the orbits or the shell, as we can see in this picture also. So the circular paths are your orbits or the shells which are surrounded by the centrally located positive charged nucleus. Each of the circular path, they have a fixed level of energy and are called orbital shells in terms of this atomic model. Thirdly, the energy levels of the electrons at different orbits are represented by 1, 2, 3 and 4 as shown here also. We can see 1, 2, 3 and 4, which are termed as your quantum numbers. These numbers are assigned to the shell such as K, L, M, N as shown in this picture also. K, L, M and N. These are the shells which are given the quantum numbers as 1, 2, 3 and 4. The lowest energy level of the electron is N is equals to 1, which is the closest to the nucleus and generally said to be the ground state. And lastly, by gaining the energy of an electron, which can jump to an orbital shell with a higher energy, and by losing the energy, it can jump to a lower energy level also. So this was all about the postulates which were given by the Niels Bohr for the atomic structure. Now coming on the limitations, what were the limitations in his model which he gave about the atomic structure, which were? So firstly, it was not able to discuss or doesn't comply with the Heisenberg's uncertainty principle. The Niels Bohr atomic model, the hypothesis considered the electrons to have both known position and the momentum simultaneously, which is unthinkable as indicated by Heisenberg. It was also didn't make the correct predictions of the large sized atoms and provided sufficient information only for the small atoms. Thirdly, it doesn't clarify Zeeman impact when the spectrum is split into few wavelengths within the site of a magnetic field. And lastly, it doesn't clarify the Stark's impact when the spectrum gets separated into almost negligible lines within the site of an electric field. So these were all about the limitations which were observed in the Niels Bohr's atomic model. Now coming on the next, that is the modern atomic model. Modern atomic theory gives a very brief explanation of the atoms and its behavior. It states that the atoms are divisible and composed of subatomic particles. the electrons are found in the orbital revolving around the nucleus, whereas the protons and the neutrons, they form the core of the atom. Exactly, if we talk about that, this modern atomic model, it was developed, it was just the rediscovery of the drawbacks which was seen in the Dalton's atomic theory. So now we are just going to compare the Dalton's atomic theory, what were the drawbacks of the Dalton's model, and what postulates were figured out, from which postulates were just transferred, were rectified, the drawbacks of the Dalton's theory in the modern atomic theory. So firstly, if we talk about what डाल्टन ने क्या कहा था, फर्स्ट डाल्टन का जो पॉस्टुलेट था उसके अकॉर्डिंग डाल्टन ने बोला था कि जो एटॉमिक पार्टिकल्स जो होते हैं ये सारे एटम्स इंडिविजिबल होते हैं, इन्हें हम फर्दर डिवाइड नहीं कर सकते क्योंकि सबसे छोटा यही होते हैं, जो एटम्स होते हैं यही सबसे छोटे होते हैं. बट आफ्टर लॉट्स ऑफ साइंटिफिक रिसर्च, बहुत सारी स्टडीज से पता चलता है कि एटम्स इंडिविजिबल नहीं होते हैं. इन फैक्ट दे कैन बी डिवाइडेड एंड उनके अंदर और छोटे पार्टिकल्स प्रेजेंट हैं जिनको बोलते हैं हम इलेक्ट्रॉन्स, प्रोटॉन्स और न्यूट्रॉन्स. So according to the modern atomic theory, atoms are not indivisible. Instead, they are made of electrons, protons and neutrons. इसमें इलेक्ट्रॉन्स जो होते हैं वो नेगेटिवली चार्ज पार्टिकल्स हैं, हमारे जो प्रोटॉन्स हैं वो पॉजिटिवली चार्ज पार्टिकल्स होते हैं, और जो न्यूट्रॉन्स होते हैं वो हमारे न्यूट्रल होते हैं, न्यूट्रली चार्ज होते हैं, या फिर हम कहते हैं उसमें कोई भी चार्ज प्रेजेंट नहीं होता है. सो ये पूरा था अबाउट द फर्स्ट पॉस्टुलेट जो डाल्टन ने दिया था कि जो एटम्स हैं वो इंडिविजिबल होते हैं, जबकि मॉडर्न थ्योरी ने ये प्रूव कर दिया कि जो ये पार्टिकल्स होते हैं, जो एटम्स होते हैं, ये डिविजिबल होते हैं एंड ये सब डिवाइडेड होते हैं सब एटॉमिक पार्टिकल्स में एज इलेक्ट्रॉन्स, प्रोटॉन्स एंड न्यूट्रॉन्स. कमिंग ऑन द नेक्स्ट पॉस्टुलेट, नेक्स्ट ड्रॉबैक ऑफ द डाल्टन्स थ्योरी. जो दूसरा ड्रॉबैक था डाल्टन्स थ्योरी का, उसमें बोला गया था, डाल्टन ने कहा था, एटम कैन नीदर बी क्रिएटेड नॉर डिस्ट्रॉयड. फॉर दिस वी कैन जस्ट से दैट इट वाज प्रूव्ड इन द मॉडर्न एटॉमिक थ्योरी, मॉडर्न एटॉमिक मॉडल, कि जो एटम्स हैं दे कैन बी क्रिएटेड और दे कैन बी कन्वर्टेड, एंड टू reactions were discovered which were termed as your nuclear fusion reaction and nuclear fission reaction. अब ये न्यूक्लियर फ्यूजन और फिशन रिएक्शन क्या होता है, जिसके थ्रू हम प्रूव कर सकते हैं कि मॉडर्न एटॉमिक थ्योरी में जो कहा गया था कि जो एटम्स हैं कैन बी क्रिएटेड और कन्वर्टेड, वो क्या होता है. सो अकॉर्डिंग टू द टू थ्योरीज, द फर्स्ट थ्योरी इज द न्यूक्लियर फिशन रिएक्शन. इन न्यूक्लियर फिशन रिएक्शन जो बिगर एटम्स होते हैं उनको हम स्प्लिट अप कर देते हैं, उनको छोटे छोटे पार्टिकल, छोटे छोटे एटम्स में हम लोग स्प्लिट अप कर सकते हैं. इसके लिए हम एग्जांपल ले सकते हैं, लाइक योर वन यूरेनियम एटम इज ब्रोकन डाउन इनटू बेरियम एंड क्रिप्टन, एंड along with it, when the barium and krypton is taken out from one uranium atom, a huge amount of energy is also generated. This nuclear fission reaction, this reaction can be used in various sectors. For example, in the nuclear plant, where we can generate the electricity. In that pattern, we can use this nuclear fission reaction. Second reaction जो आता है हमारा है वो nuclear fusion reaction. जो nuclear fusion reaction होता है उसमें हम जो smaller atoms या जो smaller nuclei होते हैं उनको हम एक साथ फ्यूज़ करते हैं ताकि एक बहुत बड़ा न्यूक्लियर या एक बहुत बड़ा आटम बन सके. इसके लिए हम एग्जाम्पल ले सकते हैं, अगर इफ़ फॉर एग्जाम्पल वी आर जस्ट कंबाइनिंग, वी आर गोइंग टू फ्यूज़ 2 hydrogen atoms, and out of it the product which will be formed, it will be forming a one big helium atom, and along with that one helium atom a huge amount of energy will be also produced. And this nuclear fusion reaction, it can take place in the big stars like in the sun. So we can say that it is a natural source of reaction which occurs through the nuclear fusion reaction. So this was also one of the drawback of the Dalton theory, which was rectified in the modern atomic theory through the two reactions, that was your nuclear fusion reaction and nuclear fission reaction, that atoms can be created or it can be converted into a new form of atoms. अब आते हैं हम लोग थर्ड ड्रॉबैक जो डाल्टन का था. थर्ड पोस्टुलेट के अकॉर्डिंग atoms of the same element they can differ from each other in their masses. डाल्टन ने बोला था कि एक ही एलिमेंट के जितने भी एटम्स होंगे सबका मास भी इक्वल होगा और केमिकल प्रॉपर्टीज़ भी इक्वल होंगी. बट आफ्टर सम टाइम ये पता चलता है कि जो एलिमेंट्स जो स्टडीज़ हुई, डिफरेंट एक्सपेरिमेंट्स हुए, उसके बाद जो पता चला है कि एलिमेंट्स जो डिफरेंट एटम्स होते हैं एलिमेंट्स के, उनके मासेस अलग हो सकते हैं पर केमिकल प्रॉपर्टीज़ विल बी सेम बट मासेस कैन बी डिफरेंट. इस कॉन्सेप्ट को हम बोलते हैं आइसोटोप्स. इसमें एक ही एलिमेंट, फॉर एग्जांपल अगर हम लेते हैं हाइड्रोजन, जिसके 3 टाइप्स ऑफ एटम्स हो सकते हैं, इनके मासेस अलग अलग होंगे. फॉर एग्जांपल हम पहला जो हाइड्रोजन का एटम है उसको हम लोग उसको 1 यूनिट दे देते हैं, दूसरे को 2 यूनिट और तीसरे को 3 यूनिट. तीनों का केमिकल प्रॉपर्टीज़ जो होगा वो सेम होगा पर उनके जो मासेस होंगे वो अलग अलग होंगे. सो दिस वॉज one of the more drawback of the Dalton's atomic theory, which was modified in the modern atomic theory. We'll be just focusing on one more drawback of the Dalton. Now let's come to the next one, that is, according to this postulate, atom of different elements can have the same mass. डाल्टन ने बोला था कि अगर 2 अलग अलग एलिमेंट्स हैं तो उनके जो एटम्स होंगे वो केमिकल प्रॉपर्टीज़ में एक दूसरे से अलग होंगे और मासेस में भी एक दूसरे से अलग होंगे. बट अकॉर्डिंग टू द मॉडर्न थ्योरी, एटम्स जो हैं अलग अलग एलिमेंट्स के, भले ही 2 एलिमेंट्स हैं, उनकी एटम्स होंगे वो इक्वल इन मास हो सकते हैं और इस कॉन्सेप्ट को हम बोलते हैं आइसोबार्स. इनके जो भी 2 एटम्स अलग अलग 2 एलिमेंट्स के होते हैं उनके मासेस इक्वल होंगे पर उनका जो केमिकल होगा, प्रॉपर्टी होगी, वो सेम होगी. इसके लिए हम एग्जांपल ले सकते हैं आर्गन और पोटाशियम. आर्गन और पोटाशियम ये 2 एलिमेंट्स हैं जो बहुत ही अलग अलग हैं. उनकी जो केमिकल प्रॉपर्टीज़ में भी डिफरेंस है पर उनका जो मास है वो सेम है. दोनों का मास है वो है 40. तो इससे हमें पता चलता है कि ये इस टाइप के, इसको आइसोबार्स कहते हैं. इसके थ्रू ये हमें पता चल रहा है कि जो भी 2 अलग डिफरेंट एलिमेंट्स होंगे उनके जो एटम्स होंगे उन एटम्स के मासेस सेम हो सकते हैं पर उनकी केमिकल प्रॉपर्टीज़ डिफरेंट होगी, वो मानते हैं, बट उनके मासेस सेम हो सकते हैं. ये मॉडर्न एटॉमिक थ्योरी में प्रूव किया गया है. जो एक ड्रॉबैक डाल्टन्स थ्योरी में बोला गया था वो उसको रेक्टिफाई करके मॉडर्न एटॉमिक थ्योरी में बताया गया कि मासेस सेम हो सकते हैं. So this was all today for about regarding the different atomic models. I hope you all liked it. So thank you so much for watching my video.